Yeah.
Yeah.
Always correct.
Okay, morning. How is everybody? All right. I'll do just a quick reminder. You all know you've been having your CMA tutorials. I think everybody's signed up because all the slots have gone. So I'm assuming you've all either had a tutorial or you've got one to come. Okay. If anybody's not, let me know because there are no slots left now. But we'll work something out. Okay. Right. Can you hear me in the chat room? Thank you. Okay, so we've got a drawing detail session today, and we are looking at this building, which is called the CRE8 barn, and it's part of a community farm in North Yorkshire. It's not actually all that far from Sheffield, and you can go and visit it. Has anybody been to this building? No? They do. They run open days sometimes where you can go and have a look. Okay, it's quite an interesting project. So it's an existing stone barn and it's been converted to provide flexible teaching space, and the whole project is an example of sustainable farming. So this is one building in a complex on a site, and the building had to capture the sustainable ethos of the overall farm, and therefore one of the objectives for the building was that the building should be extremely low energy and sustainable. Okay, so research and design into low energy retrofit of the stone barn typology. So the project is more than it's more than just about getting the building built, but actually they wanted to research and explore what can be done with these stone barns. The Peak District has a lot of these kinds of buildings, quite big stone buildings, obviously very energy inefficient, and what this project wanted to do is to see what the possibilities were. And they wanted to demonstrate the EnerPHit potentials. Anybody heard of EnerPHit? Okay. EnerPHit is the passive house standard for retrofit. Anybody heard of passive house? Yeah. So passive house is a very low energy standard for buildings. Originally it was for dwellings, but it's now for much more than that. And you might have heard me say before, it's a terrible title because passive houses, they're not passive and they're not houses. So it's kind of a title that is stuck, but it's a title that does not describe the activity. Okay. The reason I say that passive houses are not passive is because you have mechanical ventilation with heat recovery. Okay. So, sorry, just to go back one. The EnerPHit standard acknowledges that when you're doing the retrofit of an existing building, you're unlikely to meet the same standards as a new build. So it's like a passive house standard, but a little bit reduced. Okay, but it's still quite a high standard for low energy. So these are some of the objectives. Super insulation, so lots and lots of insulation. Very stringent air tightness. So to meet passive house and to meet EnerPHit, you've got to make your buildings airtight. Okay, really important. Now, the thing about air tightness is, don't confuse it with air quality. You get a lot of people say some pretty silly things about passive house, where they say, oh, passive houses are really stuffy, there's no air to breathe, you can't open a window, it's all complete rubbish. Okay? Ventilation is dealt with separately from air leakage. So air leakage is where air is leaking through your facade uncontrollably. Ventilation is when you very carefully control ventilation. And in a passive house project and an EnerPHit project, that can be done through mechanical ventilation, but it can also be done through openable windows. Okay, so yeah, just ignore that myth where people say you can't open a window in a passive house. It's complete nonsense. Okay, right, sorry, I'm just okay. Minimizing thermal bridging. So with the EnerPHit standard and the passive house standard, because you're aiming for really low levels of heat loss, you've got to minimize any cold bridging. There's no point having a super insulated building if it's got cold bridges that are letting the heat out. Okay, just going to take 1 minute because I've lost my connection here, so I just want to make sure that it's still online. Just give me a second. No, I've lost the internet. Have you lost internet?
Just got it back.
Just got it back, thank you. That might explain it. Just bear with me a second. So in the chat room, are you getting this? Because I've lost internet here, so I've lost internet on my iPad anyway. Looks like you might still be. All right, you can still see your video, but not screen sharing, cutting out frequently. Okay. I'm going to crack on. Okay, there'll be a recording later. It must be the internet in the building which is having problems, but I'm just going to continue, okay, rather than wait. So if you're in the chat room and it keeps cutting out, then you'll just have to watch the recording later, okay? Right, sorry about that. Okay. Okay, minimizing thermal bypass. Anybody heard of thermal bypass before? Okay, let me explain what thermal bypass is. When you have a building with insulation, there's no point having that insulation if the wind can blow through it. So I'll give you an example. If I went out in a windy day and I've got a jumper on, okay, if there's no wind, that will insulate me quite well. If I go out in the wind will just strip through it, take all the heat out of that wool, and I'll lose all that heat. If I put my jacket on over the top, which is windproof, I get rid of that thermal bypass. Okay? And it's the same in a building. You've got to make sure that the wind cannot just sort of cut through the insulation. Okay, structural stability. The existing barn here had a number of problems. So it needed some help, basically. As it was kind of in a bad state, and you couldn't have just overclad it and insulated it. They needed to help it out a bit and fix a few problems. Okay, and the prevention of water penetration through the external barn wall and rising damp. So a barn, a stone barn, is designed for animals, pretty much, or for storing, I don't know, crops or whatever. So it's not really designed to be watertight as such. But obviously, because this was going to be like a classroom space, had to be made watertight. Okay, quick look at some of the key objectives. So the EnerPHit standard, your heating load for the building cannot exceed 25 kilowatt hours per square meter per year. Passive house is 15, and that's pretty low. Okay, it's a pretty low standard. You will only achieve that if you've got really good levels of insulation. And then the air tightness, the standard is 1 air change per hour at 50 pascals. Now, don't worry too much about that, but it basically means you've got to be pretty airtight. And in order to achieve that air tightness, you have to test it. So what they will do on site typically is they take out a door or a window, they put a fan in, and they seal it up. They run that and they can test what the pressure loss is in the building, and that gives you an overall reading in terms of how much air you're losing. What you can then do is, with the building pressurized, you have a smoke pencil. You can go in the building with the smoke pencil, and that helps you to find where the leakage is, and then you can do something about it. Okay. Now, chatting to Paul Tester, Paul runs Paul Tester Architecture, and they do a lot of EnerPHit projects. He was telling me what they now do on site with their contractors is they keep a fan installed throughout most of the build, so that at any stage in the build they can shut all the doors, shut all the windows, pressurize the building, and use a smoke pencil to find leaks. And that's pretty innovative. That's not normally been done before. But what they're doing is saying, rather than wait until the end, let's continually test it. Let's keep looking for these leaks. And it's got to be pretty airtight. The kind of figures that I've heard mentioned are things like, if you took an entire house, the sort of area of openings in the wall, the leaks, in other words, if you added them all up, there can be no bigger than a 20 pence piece. So you can't have gaps. It's got to be really airtight. And this is important because at the moment this is kind of key to passive house, but this will become standard as we try and make our buildings more and more energy efficiency. Airtightness will be part of your day-to-day life as an architect. Okay. Okay, so the existing building was a barn, as I've said. It was not intended for human occupation, so they had to make new openings. So the existing windows, which you can just about see in the background there, were never big enough to let enough light in, so they had to make new openings. And yeah, the walls are in poor condition. If I just quickly draw over this, okay, so we can see here we've got some steel straps added onto the corner of the building. So that building, that existing stonework was clearly not working well. There was a risk of the building collapsing. You can see we've got all bits of infill here. We've got some pretty sort of crummy, low quality stonework here. And what else? You can see there's obviously been lots of leakage. So we've got all these dirty streaks down the building. So it's not in, it wasn't in great condition. Okay, now, this is a little bit detailed, but when you're certifying a house to Passive House or EnerPHit standards, normally you have to do calculations in a piece of software, and that's called PHPP, and you have to basically plug in all the parameters of the building, and you have to check, you have to verify the energy performance. Now, in this building, they didn't do that. They did it through an elemental route. And what that means is every part of the construction had to meet the standards. So in terms of the insulation levels, the air tightness, the windows, etc., etc. But they didn't do the overall calculation. Okay. And well, it's a little bit complicated, but the reason they didn't do the calculation, if I draw a really, really rough section through the building, there's the section through the building. They intended to put a mezzanine level into the building. Now, when you're calculating your passive house, you look at how much floor area you've got compared to the envelope. Because if you have lots of envelope, you're losing lots of heat. Now, for reasons to do with the structural stability of the building, the mezzanine was never built. Okay. Now, what that meant was, as soon as you take that mezzanine out, you end up with a really inefficient envelope to floor area ratio. Okay, it's called form factor. So you end up with a building where you've not got a lot of inhabited floor area and you've got a lot of envelope. Okay, so it was never going to pass based upon the form factor. Okay, now I think it's good for you to be aware of this because there's a few reasons actually. When you go out into practice, more and more practices are now using Passive House Standard and EnerPHit Standard. Archetype being probably one of the best examples of a really good architectural firm that are now building Passive House Standard into their day-to-day design. They are training, many of their architects are now getting trained as Passive House certifiers. So that's one reason why it's good for you to know, but also it's good for you to have an awareness because you might want to build this into your projects. Either in Y5 or Y6, you might want to aim for Passive House Standard. Now you'd have to do a little bit more research to understand it, but it's really good that you have that awareness. Okay. And also I think it's really important to look at retrofit, because in the UK, retrofit is what we're going to be doing. We're not going to be building loads of new buildings because we've got them all. So, you know, in your architectural careers, probably 60–70% of what you're going to be doing is retrofit. And, you know, building new is not going to be a major part of what you do in all practices. So it's good to think about it. Okay, so one factor in this building, it's got quite a nice oak truss. So you can see it there. Okay, quite a nice feature. It kind of expresses the the structural system. It talks about the materials. It talks about what it was made of. Now the problem with it is it's very difficult to expose it internally because once you start insulating the building, you're going to lose it. And you'll see when we get to some details later, because the building has been insulated on the inside, you do end up with I think a rather unsatisfactory appearance where the end of that truss gets buried in the wall. And in fact, I'm just going to go back a few to show you that. So there. So, you know, for me, I can understand why that is necessary, but I find it unsatisfactory to have a nice truss element that just kind of goes into the wall. And, you know, there's no good resolution. You just have plaster hitting wood. And, you know, practically when you you know, when somebody tries to repaint that wall, they're going to get a bit on the wood and try and clean it off and make a mess. So, you know, I think it is a little bit unfortunate, but equally difficult to avoid, I suppose. Okay, looking at a few photos on site. So, starting with the ground floor, and this is what is called a cavity drain membrane. And I'll do a really crude drawing of this. What it is like, what it is a plastic sheet that's kind of studded. Whoa, it's a really bad drawing, but it's kind of like that. I'll draw it with a pen later, and it'll look a bit better. That sits against the existing wall, and what it means is any moisture can drain. It can drain in the cavity, so it can basically trickle down behind the membrane, and then you have to deal with it. So typically that would go into a sump, and the sump would have a pump that pumps it out, or in other situations you may just continuously connect the membrane, and we're not talking about lots of water, and you might be happy enough for it just to let it disperse through the wall, and that's what they've done here. In fact, we'll draw that in a minute. Okay, underpinning. Who's heard of underpinning? Yeah, a few of you. Yeah. Okay. So what underpinning is, it's all about when you've got an existing building. The foundations of a building like this are made of stone. It's you know, it's just sort of stone rubble. I'll do another really crude drawing. So the wall comes down, and it sits on a stone foundation, all right, which is pretty, you know, pretty crude, not very strong, like that. And when you then come to improve these buildings, often the foundations have settled and they're just not adequate. Okay, so what you do with underpinning is, piece by piece, you're going to pour some really good quality concrete under the foundation, like that. And that will stop the building from settling and moving about. You've got to do it piece by piece, because you can't obviously excavate under the entire building, because there's nothing holding it up. So on the right here, what they've done is they've done a, I don't know, about 500 millimeter length of the building, and then they just continue and move along till eventually you've underpinned the entire building. Quite expensive. Okay, next one, and we will definitely draw this detail later. What they did on this building, effectively they built a new wall inside the existing wall, and in order to connect that back to the original wall, what they've done is they've cast these concrete pads into the wall. So they've dug out a sort of a, I don't know, 500 millimeter square of stonework. They've poured in concrete, take off the formwork. You've got something really solid to fix to. So you can then fix that new wall to the existing, which is stabilizing the existing and it's stabilizing the new. And this is kind of what it looks like. So what we've got here on the right is the new timber wall. It's got a noggin, which is a piece of wood, and that's fixed between the uprights. and then using one of these dowels, that is then drilled and fixed into the concrete, tying the two together. We'll draw it. And that's yeah, that's kind of what it looks like. So this is the inner wall. So you can see we're inside the barn now, and they've effectively kind of built a complete new building inside the existing building, and that gives the depth of insulation. It also gives the air tightness that is needed. Okay, quite a major piece of work. And sorry, at the roof level, they've raised the roof to get enough insulation in. So if I just change colour here. So here, I think they didn't want to completely lose that truss within the insulation level. So what they've done at the roof is they've built on top so they can get that extra level of insulation without completely losing the truss within the depth. That's a view of it sideways on. Just a few things to point out here. This is a wood insulated wood slab. It's the product is what's it called, Pavatex, and it's a wood fibre insulation board. It's a really good product actually. It's tongue and grooved, so as you see here, you can slide it into the adjacent board. It insulates. It's pretty strong. And what they've done in this building is they pretty much kind of wrap that over the roof. The good thing about it is there's no cold bridge through it because it's continuous. Whereas if you compare that with the roof, every time you have one of these rafters, you've got a cold bridge. But then by wrapping the Pavatex or the wood fibre board, you cut out any cold bridge. Okay. Now on the left, the thing to note here is the taping. So to make the building airtight, everything gets taped up. So we've got an airtight chipboard product underneath, the insulation on the wall, and then this blue tape which is taping everything together. And that's what makes the airtightness. Now, one consequence of adding all this insulation depth is the reveals become incredibly deep and your walls become really thick. Now, in this building, they've kind of benefited from it. So you see the door has quite an interesting sort of character to it, where you go through this thick wall. The windows are set well back. Now, if you had bigger windows, that would be useful in terms of getting some solar shading to your windows. The other approach that you can do is you can push the window to the outside and create a window seat using the depth. So that can be quite a nice way of dealing with it. Okay, but again, going forward in your careers, you'll be building buildings, with quite thick walls. So it's good to start to think about what are you going to do with a thick wall. Okay, I'm going to do some drawing now. Has anybody got any questions before we move on to the details? Okay, right. We're doing pretty well for time. We might be able to finish this within the hour. Let's just see how we go. If it's dragging on, we'll have a break. Okay, but if we're feeling like we're done, then we'll just finish in one continuous push. Okay. Okay. Right. So I'm going to start by drawing the base of the wall and the ground bearing slab. Okay, so starting with the external wall. Now the external wall is pretty thick. How thick is it? It's 500 millimeters thick. All right, and the way that walls like this were made is they would typically have an inner leaf and an outer leaf like this, okay? But not to be confused with a cavity wall. It's not a cavity wall. This is full of just rubble. Okay, so it's not you can't insulate in here. So what they would do is as they were building the wall, they would just fill this with rough pieces of stone, bits of mortar would just get thrown in there, so it becomes a kind of a solid wall. All right, so there's no scope for insulating in here. Okay, I'll just very, very crudely draw some joints onto it. Okay. Right, so let's get into the detailing. So the first thing that they've got is about 150 millimeters of hardcore. Okay, so by hardcore we just mean sort of gravel, or quite often quite coarse gravel, which you simply lay out on the floor, and it gives you a base to start to work on. All right. The terminology for hardcore in the UK is typically a kind of diamond hatching like that. It does get a bit confusing because certainly in Germany they use a similar hatching to indicate rigid insulation. So just have to be careful with that one, that you don't confuse the two. Okay, on top of that we've got 25 millimeters of sand, and the sand is important because if you try to lay a waterproof membrane onto the hardcore, it is very likely to get punctured. So what the sand does is it just smooths it off. Okay, right, and then we've got a piece of insulation okay, so a piece of rigid insulation placed up against the perimeter wall, and I will draw this with a sort of diamond hatch to indicate that it is rigid insulation. Okay, and the next stage is to get this all watertight. So the next element is the studded waterproof membrane, and that is laid continuously across the sand, and the joint where my finger is now would be sealed up to make it watertight. Okay. You wouldn't always need to use the studded membrane across the horizontal plane. That might just be a more conventional membrane in a lot of situations. Okay. And then we've got 200 millimeters of insulation. So a really, considerable depth of insulation, because obviously we're trying to minimize heat loss wherever we can. Okay, and again, that is a rigid insulation because we're going to lay the concrete slab on top of it. Okay. And then, so on top of that is a 150 millimeter thick concrete slab. Okay, so the concrete slab, it's above the insulation, it's above the damp proofing, so it's dry, it's warm, there's no cold bridging, so you've got a really good base level slab to then continue your building from. Okay. Right. So what I'm now going to draw is where my hand is this inner wall, and it's going to have to go over the join of my book, unfortunately, but never mind. Okay, so first thing is we have a cavity. So keeping an air gap between the existing stone, which could be damp, and our new wall. And it's a 50 millimeter air gap. And then what they've done is they've used the Pavatex wood fiber insulation next. So I'll just quickly draw that in. Okay. Now, what they actually did in this building, because they were a little bit concerned about damp coming through the wall, they actually inserted damp monitors in the cavity. So where I'm pointing to now, they put some damp sensors in there so that they could get a live update on the presence of moisture. Now it's not a problem for the existing stonework to be damp, that's what you'd expect, but what they did not want was any damp getting across the cavity and getting the insulation wet. And I think they tested it for a year or two, and they were pretty satisfied that it was working. Okay. Right. So next thing, to make the internal structure, what they've done is they've not used timber, solid pieces of timber. But what they've done is they've used the composite true joists. So it's a product that is used quite often now in kind of low energy building. And what you've got is you've got two softwood members and fixing those together is a chipboard web. Okay, so you end up with a beam or a column which is quite thick, but the benefit of using the chipboard as the web is that it does not transfer much heat. So it's a very sort of good way of building a timber frame without transferring heat through it. Okay, then on the inside, and it's right on the joint of my book unfortunately, is a chipboard liner. So the inner face is chipboard, but it's an airtight chipboard. Okay, it's not any old product. It's a special airtight quality chipboard. Okay, and then in the full depth we've got is it mineral wool? I think it's mineral wool insulation in the wall here. Okay, so if we look at the overall wall build-up now, we've got the outer stone wall, which is 500 millimeters thick. Doesn't really contribute to any insulation, but it does keep the rain off and it does keep the wind off. Then we've got an air cavity, which again doesn't really contribute a lot to the insulation. We've got 50 millimeter mineral fiber insulation board. We've got about 240 millimeters of mineral wool, and then we've got chipboard. So you can see the sort of levels of insulation that the building manages to achieve. And what it then means is we end up with a wall which is about 900 millimeters thick. So you end up with this really, really thick wall. Okay. Any questions on that element of the detailing before we move on and look at another one? Yeah.
What do you say that thing onto the mineral wool is called? That wooden piece together.
I think they're called true joists, but there are different brand names now. True joist is the name I'm familiar with, but I'm sure they come in different different names. Okay. Right, okay, let's move on. I think we're doing okay for time. I think we'll probably keep going for a single session. Is that alright? Is that alright in the chat room? You're probably in bed in the chat room. You're alright. These people have had to walk here. Okay. Right. Right. What I'm going to look at now is a plan view, okay? So we're looking down now on the wall that we just drew. Right. So start with the existing wall. And what I'm going to do is draw one of the pads where they fix the inner wall to the outer wall. Okay, so on the outside we've got stone wall, and on the inside we've got stone wall. And where I'm pointing to now, this is where they excavate a pocket. So they take out stonework till they've got a sort of about a 400 millimeter square hole in the wall. Okay, and because it's only 400 millimeters, the wall is not going to collapse around it. It'll it'll kind of hold itself up. And then into the hole they cast concrete. So they put a bit of plywood. So where my ruler is now, they put a bit of plywood over the hole. They pour the concrete in a very liquid mix. They probably vibrate it a bit. Let it cure. Take the plywood off, and they're left with a concrete pad cast into the wall. Like that. Let's quickly put a bit of shade on that, I think. Okay. The rubble that's on the inside of the wall, that will get stabilized because the concrete, in reality, I mean, I've drawn this concrete like a beautiful neat block, but in reality that concrete will just sort of bleed into that rubble until it's filled all the adjacent voids, and in doing so it stabilizes all of that internal rubble fill. Okay, like that. So again, looking down on the wall, plan view 1 to 5. So then we've got the 50mm cavity again, and 50mm wood fibre insulation, which we looked at when we were looking at the roof. That was the tongue and grooved board that I pointed out. Okay, just quickly put a bit of hatch on that. And then what we'll do, we'll draw the rest of the internal wall, and then I'll draw the way that it's fixed back into the concrete pad. Okay, that'll do. Right, so let's just have a quick look. Yeah. So then we've got these eye joists, and they are they're vertical as well as horizontal. So I drew them in the horizontal plane a minute ago, but these ones are now vertical. They are at 600 centres. Oops. Okay, so they've got this chipboard web that I mentioned before. Okay, and then the airtight chipboard over the top. Like that, probably 18mm, I would have thought, for that chipboard. Like that. Okay. And yeah, so then to fix it back to this concrete pad, so what they've then got is the timber noggin fixes across between the joists, the screw joists, like that. No, it doesn't. No, it doesn't. It fixes at the front here. Sorry. fixes here. That's where it is. So ignore this one. Okay. And then the tie. So they drill out the concrete, and they glue in using a resin a tie into here. That tie comes all the way through, and what they tend to do now is, because you don't want to have a steel tie, which is a cold bridge, you have these sort of low conduction ties, which are made of, well, one is made of basalt. It's like a rock. I don't quite know how they work, but it's like ground up basalt chippings glued together, I think, and it makes a very sort of low energy, low conduction tie. So that comes all the way through, and then there is a big washer and a nut holding that back to the timber. Okay, so now we've tied together the existing wall to the new wall. So, as I mentioned earlier, they're kind of both helping each other out. So we're stabilizing the existing wall, and we're supporting the new wall. Okay, and then we fill this cavity with the mineral wool insulation, like that. And likewise here. And over here. Okay, so almost finished, but what I just want to show you then is the approach to air tightness and the inner linings. Okay. Now, if you remember back to when we looked at the Enterprise Center by archetype, it's a very similar system that they're employing. So what they do is, the chipboard is the airtight line, so any joints in the chipboard get taped up to make sure that that's completely airtight. And then what they do is they create a wiring or a service zone in front of that. So that would probably be 50mm battens. So just softwood battens screwed to the chipboard. Just screwing battens into the chipboard is not going to create an air leakage, okay? Because when you screw the batten onto it and pull it tight, it seals up the joint, okay? And then in front of that is the plasterboard. Okay. And then what that means is that any wiring or even small pipe work can go in the gap where my finger is. If you need to put a socket in, you can sink the socket through into that cavity, and you're never ever going to puncture your air tightness. Okay. Any questions on that? Yes.
Could they have cast the ties into the concrete when they were pouring it the first time, rather than drilling out and then putting?
Yeah. So the question is, could they have cast the ties into the concrete while they were doing it? Yes, the answer is they could. I think a few reasons why they wouldn't do that. One is you would be left with a tie sticking out the wall. So that could be a health and safety hazard, and you would have to protect the end of it. And you could imagine, you could imagine at some stage some operative will walk into it. It would be very dangerous if you didn't protect the end of it. Also, there's a risk that they get bashed off. So, they're busy bringing in bits of timber and they just knock the end off it. So, yeah, those are a few reasons why. The other thing is what they could do. They probably didn't do it here, to be honest, but when you drill into concrete and you resin fix an anchor, they can do a pull-out test on it. So they have a piece of apparatus where they can basically just pull on the tie, and then what they'll do is they'll test it, and normally it's the figures will come back 10 times stronger than you need, and the engineers are very happy with that. They wouldn't necessarily test them all. So I think nowadays, they tend to drill it and resin it. And it's pretty clever the way they can do it. They've actually you get these little glass ampules of resin, so you can drill the hole, blow it out to get the dust out, you put the glass canister in, you put your tie in and break the glass, and the resin just sort of goes everywhere, and then it just bonds, and within 10 minutes it's cured. So it's pretty advanced stuff. Equally, you can do it with an expansion bolt, and as you tighten the nut, the bolt expands into the concrete and incredibly strong. Yeah, it's never that's never the architect's design anyway. That's always for the engineer. Okay. Yes, another question.
If they were worried about damp getting across that cavity, why couldn't they just put in a DPM layer or something like that?
Yes, the question is why, if they're worried about damp getting across the cavity, why not put a DPM layer in? Few things. One, it'd be very difficult to fix it, because if you imagine where my pen is now, you'd be trying to fix a damp-proof membrane first before you've got anything to fix it to, if you see what I mean. So you'd have a cavity and then you'd be trying to... So I think that's one aspect that it'd be practically very difficult to achieve. I think maybe also a concern about breathability, because at the minute, if you imagine, if any moisture was to get into that insulation, then the heat from the building would push it through. It would get into the into the air cavity, and because that's ventilated, you disperse it. If there was a watertight membrane where my pen is, even if it was a breathable membrane, there could be a risk of trapping the moisture. So yeah, but good point. Yeah. Any more questions? Yes.
On the image before, there looked like there was some aerospace formwork on the exterior of the rather than the interior. It was just one of the images you showed before. There was like squares of OSB on the external wall.
Yeah.
Was that? Because this looks like it's going on internally.
Let me get the image up.
Yeah.
Yeah. Just bear with me a second. So the question was, if you can't hear it, it looked like there was some OSB on the outside. Stop me if you see it, okay.
There. Is that to stop the concrete from coming out of the gaps and stuff?
But it's on the inside.
What? Oh yeah.
Yeah, it's on the inside. It's all right. I think what they were probably quite careful to do was to try and not break all the way through to the outside. Although in reality, when we go back to look at the outside of the building, they must have done a lot of new stonework to repair that anyway. I mean, it's a right mess, to be honest. So even if they had punctured all the way through, I'm sure it wasn't a big problem. Okay. Any more questions? Okay. I'm not going to do any more drawing, but I just want to show you one or two other things. Oops. Before we finish. Okay, so what I just want to show you is the window detail. Okay, so at the same scale, that's what the window ends up looking like. So you can see the sort of massively thick wall, and what they've carefully done is position the window on the line of the insulation. They've insulated the gap, so there's no cold bridge there. And then to cover the existing stone wall, they've actually used an aluminium sill to cover that. Now you could have done that with a nice stone sill, which maybe would have looked more in keeping with the vernacular, but they've gone for an aluminium sill to cover that. Okay, and then on the inside, they've just put a timber sill where my finger is now. Okay, just to cover that, and then the service void that I mentioned, where my finger is there. Okay, and at the window head, a little bit more complicated. Where am I pointing now? When they were making a new opening, what they've done is they've put a stone lintel on the outside, so that it is in keeping with the rest of the building. And on the inside, that's my pen, they've got two concrete lintels to form the opening. Okay, and then there's a little bit of a complication at the window head in the cavity, where they've had to put a cavity tray over the top there, just to make sure that if there is any moisture in there, it will be evacuated out of the cavity. Okay, and then very, very last one. I'll make all these available to you if you want to look at them in more time. Okay, so the very last one is the eaves. So we get up to the roof. So there's the wall. Slightly different here. To stabilize the top of the wall, they've actually cast a continuous concrete beam into it. So they've excavated and they've actually cast concrete all the way along to make it really stable. And then, so where my pen is now, that is the top of the existing rafter or truss, and then they've added on top the additional rafters to create that extra insulation, and therefore they've raised the roof level to achieve that. Okay, and the wood fibre board gives this continuous wrap all the way around the roof, so there's never any cold bridge. Okay, any questions? No? Any questions in the chat room? Okay. Okay, well if it's alright with you, we'll just finish there. Okay? And I'll make these available. You might want to have a look in a bit more detail in your own time. Okay, thank you.
Should we go inside the library?
Exactly. Yeah, we need to go inside to go.
Alright, thank you.
Everyone just associated with the character.
Thank you.
Did you
Thank you. Thank you.
Cheers, thank you.
Thank you. Hi.
Hello, Dusk. So a few weeks ago you sent out that email with the job
Yeah.
to model buildings and to get a reply. So I presume I wasn't picked. I mean, I did it very quickly. My
What's your
response to
name?
that, Lucas. It was the Stirling Prize one.
But you-
I just thought-
Did you put it on the form?
Yeah, I thought I sent it through. You know, on the link you gave.
The reason I wrote back to everybody yesterday,
Oh, did you? Oh, right.
and everybody who submitted got through.
Okay. Maybe I just haven't seen the email yesterday.
Okay, I'm just a bit nervous in case you.
I know I didn't probably haven't checked my emails yesterday.
I think you were on my list actually.
Oh,
Okay, so basically,
so everyone.
Well, I'm just. Thank you. I'm worried now that I've got the wrong.
Actually, you probably have so many emails.
Lucas Williams,
Yeah.
10.
Yeah.
L Williams 10. Yeah. Yeah.
Oh, sorry,
Emailed you
seen it.
yesterday.
Oh, great. Okay.
Yes.
Okay.
Thank you.
Okay. Great.
You're on.
Thanks.
Hi.
I sent you an email yesterday about the concrete tiles. I just want to check in terms of
Yeah.
section.
Yeah.
Because I'm focusing on this courtyard space. So my idea is to sort of have arches on the ground floor, probably because there is an existing steel frame, and I want to case that with concrete, and then above that I'm going to have those concrete tiles. So I was just sort of looking into hexagonal shaped ones.
Oh, yeah.
I just found
Yeah.
precedent because my themes are integration of nature and also culture. So I'm trying to like look at how I could integrate planting and then
Oh, yeah.
patterns
Okay.
to represent that.
Yeah.
So in terms of section, I was just not. I don't know if this is right, but I was gonna have the tiles, and then after my tech tutorial, I was recommended to have cross timber battens, and then the damp-proof membrane insulation and the steel frame. I don't know if that's correct. If
It is correct. Yeah.
Oh, okay.
Different ways of doing it.
Yeah.
I'm going to ask you to draw bigger.
Yeah. It's just. a
I'm
sketch.
struggling. I know, but
Yeah.
I'm struggling, so you're struggling.
Yeah.
I suspect. So draw that at 1 to 5.
Yeah.
And I'm going to quickly do it now. But what are your tiles made of? Are they ceramic?
Concrete.
Concrete, okay.
tiles,
So, a few things to think about with tiles is you want to be able to fix them, so they might want to have a shape on the back. So I'm just making it up now, but for example, imagine if this was your concrete tile
Yeah.
and it was cast with a kind of shape on the back of it. Now you've got something to hang it off potentially, so you could have a little, like a recess or something. And so that could take, you could have a stainless steel clip or hanger, so you can rest them on.
Yeah.
Now you can only explore this if you draw it bigger. You can never
Yeah.
do it at that side.
Yeah.
Okay. So now you've got something that you can sit it on,
Yeah.
because tiles normally rely on, a normal a roofing tile is normally something like that. So it's got this bit that can hook and hang on to something. Okay, so you've got that. Then you've got vertical and horizontals. Probably doesn't particularly matter which order you put them in, but let's say I'm going to do vertical timber battens.
Yeah.
And then horizontal timber battens, maybe. No,
So-
better the other way around, actually.
Yeah, because are they going
Yeah.
to be hung onto the horizontal patterns?
Well, it's up to you. I would do that the other way around.
Okay.
The reason is, if you put that horizontal batten now against to a board product, you could trap water. So better the other way around.
Okay.
Right, let's just quickly change it. So let's put them like that. Where's my two pencil? Okay. So what you could then do is you could have a board product, so plywood for example, and that could have a breathable membrane taped, stapled to it. And then you're into a normal wall. So it could be the wall I just described here, using these joists.
Yeah.
So you could do it like that. So you could have and that would be a good sort of low energy way of doing it, like that. Got a bit of a cold bridge, so you might want to then insulate here. Equally, you could do what they've done. You could put the wood fibre board in front of the plywood, or in place of the plywood actually, and that gets stuffed with insulation.
Yeah.
That's all good.
The steel frame, because there's this existing frame, and
Mhm.
I was just wondering how I would attach all of that onto the steel frame. Would that come?
I don't know what it looks like.
Okay.
You have to bring it and you have to draw it.
Yeah.
Yeah, because I can't. I don't know.
Yeah.
I don't know. Where
Yeah,
is it
fair
here? Is it
enough.
here? Is it there? I don't know. Is it round, square, rectangle? Who knows? But that's why I keep saying to you, just draw it big.
Bigger.
Yeah. I mean,
Yeah.
that's a pretty crappy drawing I've done, but it was big enough to really
Yeah. to
think
really
about
do
things.
that.
It's pretty rough, but
Yeah.
you'll never explore that at that size.
Yeah.
It's teeny.
Yeah.
All right.
Thank you.
And I mean, also, that was really badly drawn. But if I'd drawn that a little bit better, I might have had something. Actually, you could say, that's all right. I can put that on a sheet. It's a bit wobbly, but it's not too bad. That was a little bit bad, but.
No, I agree.
All right.
I will start doing it bigger.
Yeah.
Yeah. Thank you.
Okay.
I have the same question.
Yes. Okay.
Quite a small drawing as well.
Okay.
It's not as small.
Okay.
Okay, so I have a timber frame which is going like this into the ground. So this is the column. So it's kind of like a glue lamp, but I'm experimenting with a material made out of like newspaper. So
Oh, yeah.
it's like glue lamp but with newspaper as the wood substitute. So I want to try and have use as much newspaper in the build up. So having like a CP board or sheeting board made out of like a compact newspaper as well, and then the composite newspaper installation. So I was just trying to work out the build up, but how, because I want the framework, because obviously like I want the material to be exposed on
Yeah.
the interior.
Yeah, yeah, definitely.
So I want to have that. So I was looking at in plan having this sort of timber coming out and then the secondary structure, like sort of framing
Okay.
timber battens inside and packing that with insulation and having, but I then need this line of insulation behind all of that as well.
Well, my question is, how much do you want to see of that? Is that that?
Yes.
So, if I was to draw that in plan, do it over here. You know, there could be an argument to say, let's not bury that beautiful
Keep it
structural
all out.
post into the wall. I mean, you could do, but I would say, why not have it? Have it on the inside. It'd be lovely. You could put little seats in between it, or whatever. In which case, this is your newspaper sort of structure. If I draw it the same way you've got it, then you could. Well, you could do the same build-up that I've just drawn today, using the joists, chipboard in here. You might not mind losing a little bit, so you could put plasterboard in there, and then just repeat that build up. So you've got your wood wool over the top. I've run out of page, but keep going.
Yeah.
Or if you go back to the archetype enterprise centre that I drew earlier in the year, they did. What did they do? Slightly different. They did the insulation. So I think they did like that, and then they put insulation on the inside.
Yeah.
So it overlapped.
Because that's going to be a coal bridge there, isn't it?
It is, which is why if you put the wood fibre on over the outside, it's no longer a cold bridge.
Okay.
So that might be the way to go.
Yeah.
And then your tiling just goes on the outside there, and then this gets the full floor.
So when this meets the floor here, so I was going to put that into like a still sort of plate, and then bolt it through there. But how does that like threshold there work with like in terms of like water ingress? Would I have to have something like that so I have like a sort of like a plinth that it sits on?
Yeah.
And then
that would be quite normal.
And then would that brickwork, that blockwork there, would that sit on top of that blockwork? Because that's thicker, isn't it?
Well, just get a paper. If you go back to last week, I was drawing brickwork. There's my time. So one thing I drew last week, perfect, thank you, was that idea of a step.
Okay.
So what that would let you do is get your brick plinth up. That's a massive gap. Your post would be sort of here, fixed back to the concrete like that, and then your cladding is going to end up somewhere out here.
And then that whole build up. Sit
yeah.
In here.
So your chipboard is there.
And then
like that, and your tanking. Where's my blue? You draw the tanking in blue. Bring that around, lap it around, stick it up there a little bit.
And then my what's it called, this thing?
Cavity tray.
Cavity tray.
Yeah.
Can sit on top of that brickwork.
Yeah. Absolutely. Yeah. So you kind of that, but but replace some of this build up with what you want, and that would do it quite nicely.
Okay. Yeah, that makes sense.
And one thing that people often do is they use very dark coloured bricks here, and you never see them.
Yeah.
You know, so don't agonise over what's it going to look like with my lovely cladding and then this little brick thing.
Yeah.
But they're just so dark that you just never see them.
Okay.
You never look at them.
Yeah, that makes sense.
Yeah.
Do you mind if I take that?
No.
Thank you.
Go for it.
Can I take that one as well?
Yeah.
Thanks.
Yeah. And you're both going to go and buy a bigger pad of paper today?
Yeah.
Or, you know, all this stuff's good.
Yeah.
Get 100
Yeah,
metres for
I
20
can always
quid.
lose that though.
True.
I prefer it all
True.
in one book.
True. I put my name in it normally. I know what you mean. You're in the studio and it's gone.
Disappears.
Yeah.
Aiden, can I take
Yeah.
a picture of that?
Yes.
I don't want to rip it out of the book.
Yeah.
Thank you. Great. Thank you so much.
All right.
Thank you.
My pleasure. But you know, I do mean it. Draw it 1 to 5.
Yeah.
Yeah.
I think you'd be quite surprised at how things start to make
Yeah.
sense. And I mean, the other great thing about that is you're more happy normally to draw it and just rough it and then do it again and do it again.
Also, for the CMA assignment, the dimensions you've set up, I've tried to put them in the InDesign, but is it supposed to be really long and horizontal? Because I've tried to do the pixels dimensions.
Wasn't that just 4K I gave you? It might be a little bit more widescreen than a normal. Well, don't worry about it. Just
should I just stick to 2A1s?
yeah, 2A1s.
Okay.
It was really what it was really saying was just make sure you've got enough pixels.
Yeah. Okay.
So it's not a pixelated A1.
Yeah.
Yeah.
Okay. Great. Thank you.
Cool.
All right.
Thank you so much.
Okay. Oh.